Rio Grande graders. It's Miss Hanamiu, and it's good to have you back from winter break. It's time to get our minds rolling again. So let's go ahead and take a look at our DMA. We are on week 15. Okay, so it should look like this in the corner right here. Week 15, and we're going to be on day 1. Now, although today is Tuesday, I still want you to do day 1, and we'll just make up for day 4 on Friday. So let's take a look at our DMA. Our first problem says or asks us to write the matching multiplication fact. And as you know, or as you probably remember, that multiplication is repeated addition. And when you're writing your multiplication number sentence or equation, you have a factor, and you're multiplying the other factor to get a product. So factor, factor, product. Now remember, our first factor tells us how many groups we have. And the second factor tells us how many is in each group. So if you notice, I have one group of 5, another group of 5, 5, 5, and 5. So we want to know how many groups of 5 do we have? Well, we have 1, 2, 3, 4, 5 groups of 5. Now remember, your product is how much is the total of all of these add-ins added together. So if we know how to count by 5s, which we should, we can add 5 plus 5 is 10, plus another 5 would be 15, plus another 5 would be 20, plus another 5 would be 25. So that's our multiplication fact from the repeated addition fact to make our product. Now, our next equation is subtraction. Remember, you're starting with your total or the whole. You have part, and you're looking for the remaining or what's left of the missing part. So it's 2 parts, and we want to find what those 2 parts are from the total. So if I had 456, let's say jelly beans, and 279 of those jelly beans were white, then I would find what's left would be, let's say, purple. How many of them would be purple? Let's just say, for example. Now, I can use one of my strategies, which would be, or could be, the break apart strategy, which means I'm going to take each place value. So I'm going to take my hundreds and subtract hundreds. I'm going to take my tens and subtract tens, which would be 70 here, 50 minus 70. And then I have my ones, and I subtract ones. So basically, I'm just setting up my problem based on my place value. So here's my hundreds, my tens, and my ones. Now, starting with my hundreds, I start with my hundreds because I may have to borrow so that I can regroup. So I'm going to start with my hundreds, and I'm going to subtract 400 minus 200, and that's going to leave me with 200. Now, knowing that I can subtract 50 minus 70, I see that I have too much here to be able to subtract 70 from only 50. So again, this tells me, and this is why I started with my hundreds, I need to borrow 100 to be able to subtract. So if I borrow 100, that leaves me with 100, and I'm going to take that 100 that I just borrowed and add it to the 50, and now I have 150. Now thinking about, I have to subtract 70. So mentally, I could subtract 50 and then 20. So I'm kind of doing this in my head where I could take 150, subtract 50, which would make 100, and then 100, subtract 20 more. 100 minus 20 would be 90, 80. So this would be 80 that'd be left. Now, to double check your subtraction, you can always check by using addition. So is 80 plus 70 going to give me 150? Well, if I know what 70 plus 70 is 140. And so if I add one more 10 to 140, that would give me my 80 plus 70, and that would give me 150. Now that we've finished our tens place, now we can go to the ones place. And I'm subtracting 9 from 6, but I can't do that because if I only had 6, I cannot take 9 away from that. So I need to borrow a 10, which leaves me now with 70. And I'm going to take that 10 that I just borrowed and I'm going to add it to this 6 to make 16. Now, I can subtract 16 minus 9. Well, if I count up from 9, go up one more, that's 10. And then from 10 to 6 would make 6 more. So 1 and 6 is going to make 7. So 9 plus 7 is equal to 16. So that tells me that 16 minus 9 is equal to 7. Now I can take my hundreds place, my tens, and my ones and put them back together as a standard number. That's what we call when we take the expanded form and put it back together as one number, which would be 177. Now, if I were going to do this as an algorithm, and that means I'm lining up my place values based on their value of ones, tens, and hundreds, I can see, since I have to regroup with subtraction, I know that I'm going to need to start in my ones place. Now, the reason that we start in our hundreds place here is because I can regroup here. It's not as easy to regroup when you're using the algorithm as a strategy. So we start in the ones place when we're using the algorithm. So I can't subtract 9 from 6 just like I couldn't here. So that tells me I need to borrow a 10 from the 50, and now I have 40. I'm going to take that 6 and add 10, and now I have 16. Now I can subtract 16 minus 9, and if we did the same mathematics up here that we did before, we know that 7 plus 9 is 16. So 16 minus 9 is 7. Now, we have 40 here. We want to subtract 70. Cannot do because we don't have enough tens to subtract these 7 tens. So that tells me I need to borrow 100, which is going to leave me with 3 hundreds. And I'm going to take that 100 and regroup it as 10 tens. So I have 10 tens and another 4 tens. So 10 and 4 makes 14 tens, which is 140. 140 minus 70 is going to give me 70. Because 70 plus 70 is 140. Or 7 tens plus 7 tens is 14 tens. And then I go to my my hundreds, and I subtract 300 minus 200, and that leaves me with 100. Now, remember, you can check your subtraction by using addition. So that means you take the part that you found and add the part that you subtracted, add those back together, and when you add those back together, they should add back up to your total. So 7 plus 9, well, what if I don't know what 7 plus 9 is? Well, I know what 10 plus 7 is. 10 plus 7 is 17. So 9 is just one less, so that would be 16. Or you could use 7 plus 7, which is 14, and then add 2 more, which would still give you 16. So either strategy that you use mentally, you could use to help you figure out that 7 plus 9 is 16. Now I'm going to carry that 10 to the tens place, and I have 70 plus one more 10 is 80, And I need to add 80 plus 70. Now, 70 plus 70 is 140, plus one more 10 is 160, correct? No, 150, sorry. 140 plus one more 10 is 150. Now, I'm going to regroup that 100, and 200 plus 100 is 300, plus one more 100 is 400. So, again, double checking. Make sure that that total matches what you started with when you started subtracting. The next problem has to do with telling time on an analog clock. So they give you the digital time here, 7:26. What does that look like on an analog clock? Like a clock that you see with the digits going around in a circle on the clock. So remember, in between each one of these numbers, these hour numbers, because these are the hours on the clock, in between each one of these sets of numbers is 5 minutes. Now, we're not ready to look at the minutes yet, but I just wanted to remind you that when we start putting these little tick marks in for the minute ticks, we're going to remind ourselves that in between each hour digit is 5 minutes. So let's take a look at our hour first. We have 7 o'clock, and it's actually 7:26. So since these aren't zeros, that hour hand is not going to be pointing directly at the 7, because the only time that it points directly at an hour is when the minute hand is pointing directly at the 12. Once that minute hand starts to move around the clock, that hour hand starts to move closer and closer to the next number or the next hour on the clock. So since this is 7, we're going to use, it's not 7 o'clock, it's not 8 o'clock, but it's going to be moving towards. So that's going to be in the middle of our hours of 7 and 8. So we don't want it to be pointing directly at the 7. We don't want to be pointing directly at the 8. It's in between the 7 and the 8, in between this area right here, the 7-8 area. Now, the hour hand is the short hand. So that's why we made this a short arrow or short hand. Our minute hand is going to be the long hand. And the long hand tells us that we are going to point that minute hand at the 26. Now remember what I just said. Between each one of these sets of numbers on the clock is 5 minutes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26, 27, 28, 29, and 30. Now, easily, if we know how to count by fives, this is going to make it much faster for us instead of counting every single one of those little tick marks. So we go 5, 10, 15, 20, 25, and we need to go one more tick mark past the 25 to make 26. So we're going to point it right there. And again, remember you're making that minute hand the longer hand, and it's almost pointing directly at. It's pointing directly at that minute of 26. So that's what your clock should look like. Our next problem is an input-output table, and our rule is we're multiplying by 4. So we have a factor. This is our second factor, and this is our product. Input, output. Your input is one of your factors. The rule is the other factor, and your output is going to be, in this case, the product. So I have 2 groups of 4. My input is 2 groups, If I have 2 groups and there's 4 in each group, that means I have an output of 8. I have 3 groups of 4, which means I can add another group of 4 here. 3 groups of 4, we're multiplying by 4, that gives me 12. 4 groups of 4 is going to be 16, which means I'm adding another group of 4 to my last product. And 5 groups of 4 is going to be 20. Now remember, we're looking input to output, not output to output. Input to output, input to output, input to output, input to output. Now, let's just say, for example, what if they didn't put the next number in the input as, let's say, 6? What if they put it as 9? We would need to know that the rule, or the rule is asking us to multiply by 4. So from input, we couldn't just add 4 here to get what the product is. We would have to know input to output. So we'd have to multiply by 4 to give us our 36. And so this is why we look at input to output when we are looking at tables and working with tables that are input-output tables. So again, we will be meeting today for our live session. We'll be talking a little bit about one of these problems in our discussion for our warm-up. And so please be sure to have these done before you come to class. See you soon, and it's great to be back.